Hello, my mathematicians. This is Miss Foster with Math in Focus, Grade 4, Chapter 4, Lesson 2, Using a Table. For you to really use a table, you need to understand its parts. So one part of a table that we will always get to see is the title. This lets you know what the information is about. And without that, you may just end up with a bunch of numbers. It helps you make meaning of the data. A table also is usually formed in the shape of a rectangle, which means it has two dimensions. Going across on the x-axis, we have rows. We also, however, going up and down vertically on the y-axis, we have columns. And so those are two key parts of a table that you'll want to know. Now, where columns and rows meet, we call that an intersection. And so right here, this orange shaded in box is the intersection between the column telling the number of girls and the row for February. So now that we've oriented ourselves, let's take a look at this table and see if we can use it to find information and understand information and answer questions. Rebecca made this table to show the birthdays of her classmates in the months from January to June. All her classmates were born in the same year. Help Rebecca complete the table. So all of these boxes that are empty here are the pieces of information that we want to find out. So let's check out this intersection we were just talking about. This intersects the number of girls being born with everybody in her class who's born in February. We see, looking in this row, that there are 4 boys and a total of 6 children in her grade or in her class who have birthdays in February. So the difference between 4 and 6 is 2. So that's a way that we can figure out some of this missing information. How about in March? We don't know how many boys had birthdays in March, but we know there were 2 girls and a total of 3 children with birthdays in March. 2 plus 1 equals 3. How about April? 5 boys have birthdays in April. We don't know how many girls have birthdays in April in her class, but 5 total children have birthdays in April. Well, that means it must not be any girls were born in April in Rebecca's class. Now in May down here, we know there were 4 boys and 2 girls. What would the total be? 4 plus 2 is 6. And finally, for the month of June, we don't know the number of boys. We know there are 3 girls and 7 altogether. 7 minus 3 is 4, and 4 plus 3 is 7. Now this total row down at the bottom and at this side, they add everything up all together. So here we want to know the total number of boys. Well, it looks like we're going to be doing some column addition. We'll do it my way first. I love to find friends of 10 when I'm adding a whole bunch of numbers. And check this out. If I take this 4 and this 1, they make 5. And then if I take this 5, I've got 10. I'm left with 4 plus 4 plus 2. Well, 4 plus 4 is 8. And 2 more makes another 10. So that's 2 tens, which is equal to 20. That's how I like to do column addition, but I know a lot of people like to do it just starting at the top and going down. So let's try that for the girls. 3 plus 2 is 5. 5 plus 2 is 7. Plus 0 is still 7. 7 plus 2 is 9. And 9 plus 3 is 12. This final intersection is the total number altogether. The total number of children and this total number of children. In fact, at this particular intersection, it doesn't matter which way you go. I could add up all these numbers, or I could just put these two together. And adding 20 plus 12 seems a little easier to me. So I know that there are 32 children that Rebecca counted here. Now that we've got our table organized and all of our information ready to go, we can begin to answer questions. How many classmates were born in May and June? Well, this is the May row and the total is 6. This is the June row and its total is 7. 6 plus 7 is 13. How many classmates were born in these 6 months? Well, we just did this intersection right here, where we find out that the total number of children counted for this table of information is 32. Which month has the greatest number of birthdays? I'm going to look in this total column again and find that 7 is the largest number, and it is in the row for June. And finally, we have a question that I think is very tricky. We're going to have to really think about what the table means to answer it. It says Rebecca is the youngest among those born in March. So in March, there are 3 kids. We know that the youngest one is Rebecca. So I'm going to put 1 here for her and R for her name. That leaves 2 kids who were born before her in that month. So it asks how many of her classmates born from January to June are older than Rebecca. That means they were born before her. So if I take 2 and add it to 5 and 6, I get to 13. 13 kids are older than her. Now, if these kids are all older, these kids down here would be younger. How many of her classmates born from January to June are younger than Rebecca? All of these kids here. I already know that May and June make 13. 13 plus 5 more equals 18. And so we've used a table and what we understand about it to fill in data that is missing and also to answer comprehension questions. Let's do this with another table together. This table shows the number of bottles of water and juice sold at each booth during a fall festival. It looks more complicated than our last one, so I'm going to start looking at all the different titles and labels that can help me know what the information will be sharing with me. The title of this table is Bottles Sold at a Fall Festival. And I notice that the first column is a booth column. They had 4 different booths, and just to help us tell them apart, they named them A, B, C, and D. Now, I notice that there's a label here that goes for 2 different rows or columns. So this is saying that water is being sold, and every bottle of water is 50 cents. Here we have the number of bottles sold, and next to it in this column, we have the amount of money collected. And I can sort of see right here with these dollar signs that this is a column that will be sharing with me about money. We have a similar thing happening in the next 2 columns. The next 2 columns are all about bottles of juice, and they're more expensive. Each one costs 80 cents. Now here we have the number of juice bottles that they sold, and right next to it, the amount of money they collected. And once again, if I take a moment to look at this, I see that there are a whole bunch of dollar signs there. So this column of information will involve money. Then we have the total amount. And in this total amount, I do think they're being a little vague here, so you've got to think carefully. Are we talking about the total amount of bottles or the total amount of money? Well, when I look in the rest of the table, I can see that this is trying to show me the total amount of money. For this table, I'm going to have you do some work on your own to figure out the missing data. Let's start with the water. We know how many number of bottles of water were sold at each of our booths. And they've been so nice that they've done the very first one for us. Booth A sold 25 bottles and ended up collecting for those 25 bottles $12.50. But how did they figure that out? Well, I know that each bottle of water is 50 cents. So if 1 equals 50 cents, 2 bottles, and I'm going to use a B to abbreviate here, equals $1. So I wonder if 25 divided by 2 equals 12 and a half. Let me see here. If I took 25 and divided it in half, because there are 2 bottles for each dollar, that should tell me how many dollars I have. In the tens place, 2 times 1 equals 2 tens. Oh, look at me applying my skills in long division that we just learned. And that leaves me with 5 bottles. 5 divided by 2 is 2. 2 times 2 is 4, and that leaves us with 1 left over. Half of 1, if it's a dollar that we're talking about, is 50 cents. So it makes sense to me that it equals $12.50. So if we take the total number and divide it by 2, we can find the amount of money they collected. Before I let you get started on some of this, I want to just point out to you that Booth B sold the exact same number of bottles of water. So we already know this one because they already did it for us. What I'd like you to do now, my friends, is pause this video and figure out all the missing information for water, the total number of bottles, and all of these dollar signs that need to be taken care of. Hit pause. I invite you to check your answers against mine, and pause again if we disagree on some things. If we do, please write down a question about that, because I would love to talk about those questions when we get back face to face. If you're ready to move on, we're going to do the exact same work, but for the juice columns. In the juice columns, we have juice being sold for 80 cents each. We know the number of bottles sold at each booth, but how do we find out the amount collected? We see here that 20 bottles equaled $16. Well, if we have 20 bottles and each of them are 80 cents each, then I think I could do some multiplication here to find out how many cents those 20 bottles would cost. Now, there's a 0 in the single ones place, so I'm just going to start with a tens place here. And I'm going to get that 0 right here in the single ones place, because we see that 0 times 80 is 0. So into the tens place now, 2 times 0, another 0, and 2 times 8 is 16. But then I have to remember, I've just been multiplying cents. And they have dollar signs here. So I need to add a decimal point in front of the hundreds and the tens, right here between them and the single ones. And that's how they figured out that 20 bottles cost $16. Using that information, go ahead and you work to find your answers for how much they collected at each booth, the total number of juice bottles sold, and the total amount they collected for juice at the Fall Festival. Now we need to find the totals in this last column. Once again, they're talking about money. So I think we're going to need to add in each row, add what there is for both of these money columns. So you can see they did $12.50 plus 16 to get to $28.50. Now that we have all of our data and it is well organized, we're ready to start asking questions of it. Which booth collected the most money? I'm going to go to this total column here and notice that booth A collected $28.50, so I think that booth collected the most. Which booth collected the least money? Down here for booth C, they only collected $10. That's not very much at all. So C looks like you collected the least. Which booths sold the greatest number of bottles of water and juice? I think this one was pretty tricky to answer, but it turns out that we want to count all the bottles of juice that got sold and all the number of bottles of water that got sold, and we didn't work those calculations in when we were figuring out the rest of our data. Looks like we have to add the number of bottles of water sold and the number of bottles of juice sold for each row. Once again, hit pause and do that work for yourself. Check your work against mine. Here's what I came up with. And did you notice that in this question, they made the word booth plural? Once we look at this data, we see that booth A and booth D did sell the same number of bottles of either water or juice. So the correct answer down here is A and D. Finally, they ask, which booth sold the least numbers of bottles of water and juice? Well, this answer also comes from our extra calculations up here. Booth C really only sold 17, and they only amounted to $10, so that wasn't nearly as much as the other places. So the answer is C, which leads us to our last fine question. Suggest why this booth sold the least number of bottles of water and juice. What could have caused that? The great thing about this question is that if you can make it make sense, then your answer is correct, but it has to make sense. Friends, thanks for playing with data and tables with me. I love playing math with you. Bye-bye for now.